Good afternoon, evening, good morning, everybody in the whole world. It's good to see you all. Today I'm joined by the amazing Kat Morgan, who is going to be taking us on an adventure in Pulumi and Cilium. Welcome.
Well, thank you. I've been excited about this since we met up on Wednesday to kind of plan it out, and
Right.
then yesterday you dropped a bunch of code, and I'm so excited to get into it. I haven't even gone and looked through it because I want it to be a surprise.
So I'm excited about it too. So, as usual, let's start with our news. Obviously, if you're out there, let me know you're out there. I'd love to know that people are actually watching this stuff as we create it, and it'd be awesome to know that you're out there. So just say hi if you're out there. Let's go ahead and start with boop, the news of the week. So this is talking about the obviously this newsletter is a public newsletter. You can go and subscribe to this newsletter on the bottom of Cilium.io/newsletter. You just put your email address right here and hit subscribe, and you can see all of the past ones. This one is number 50. Lots of good stuff here. Somebody actually talking through like the ability to get first steps with eBPF. And the fascinating thing is that they're doing a userland library for Java, which is kind of wild. There's another one, there's somebody else doing snooping on libpam, trying to figure out OpenSSH, auth, and password, Golang, and eBPF, kind of understanding the kernel context for those things. I installed this because I was super curious about it, but there's a new thing called BPF top, which is a way of actually displaying runtime, events per second, estimated total CPU usage for each program, which I think is going to be fascinating. I installed it, and so like when we get to the part where I'm actually demoing stuff, I'm going to see like what it looks like because I'm going to be doing this all in Kime clusters. So in theory, BPF top should be able to see all of the BPF programs for all of the nodes inside of our clusters. So it'll be interesting to see what that looks like. I'm super curious. Other stuff out there. Actually, I guess there's two articles on BPF top. Oh, that's one announcing the project, and the other one kind of like talking about it, which is pretty neat. Kubernetes networking with Cilium, a couple of good getting started articles, one talking about routing with Cilium, which actually comes up in the thing that we were talking about, the pull request I made against your existing code base, turning off the native routing cider. And then, yeah, some good Tetragon stuff, talking about eBPF network analytics that you can get from Tetragon. I love that in French, webinar is webinaire. I did not know that.
Everything sounds better in French. No. I worked with this guy who was from French Guiana, and we were in the middle of Oklahoma, like really random place to have a French speaker. And when he got mad, he would revert back to speaking French, which was cool. And he'd be like, I'm so sorry. I was just worked up. I'm speaking French. And I was like, yeah, I'm sure you say that to all the girls, right? Like, I'm so sorry. I accidentally spoke French.
Yeah, that's hilarious. I had a friend when I was like in a past life when I was doing network architecture stuff. I had a friend who was from Canada. His name was Denis, and it was absolutely a joy to work with him because he would do the same thing. He would get when he would get frustrated, he would like slip, and then he would like calm down, you know. But it was pretty amazing. It's one of my favorite coworkers of all time. I haven't seen that dude in like 12 years, but still one of my faves. Obviously, the next couple of weeks are going to be crazy busy for so many people. We are coming up on one of my absolute favorite conferences. You hear me say this every year. It is Rejects.io. It's going to be in Paris this year, pretty close to a pretty major landmark in Paris. But lots of really good talks. There should actually be a schedule. Oh, there we go. Full presentation schedule.
Someday I'll be a cool kid and I'll get to talk at Rejects.
You should definitely do it. It's just, I mean, even if you don't talk, you could volunteer to go do like a track host or something. Because honestly, like, in my opinion, the value of, I'm always a big fan of the hallway track, like being able to connect with your peers, talking about what's happened in the space. And I would say that like the value of the hallway in Rejects is probably, I feel like at least twice as valuable to me than that of KubeCon.
Cool. I'm still pretty new at this whole like conference routine. So like it's all shiny and new to me, and I haven't gone to Rejects yet, but I'm looking forward to for KubeCon North America, at least.
Yeah, it should be amazing. Yeah, and the thing I love about it is that it's like so many of the people in our community that are just there early, and you get to actually connect with them as opposed to like seeing them briefly in the hallway, like where you're both very busy and you're trying to go between different things. Like Rejects actually gives you a chance to like actually connect before the winds of KubeCon blow you apart.
Yeah.
It's amazing. Anyway, I'm a big fan. Then, right after Rejects, we have Cilium and eBPF Day. Schedule's up. You can still register. There's lots of really great stuff in this Cilium and eBPF Day Europe. This is the first time we've actually done a combination of the two. So, like, we've been kind of going back and forth. Initially, the thing that we were working with the Linux Foundation was on eBPF Day, and that talked about all kinds of things, including Cilium and a bunch of other things that were happening in the space. Then we did a Cilium one, which primarily focused on use cases around Cilium. And now we're actually kind of evolving it once again into a combination, because we do feel like there's a really good opportunity to talk about like what people are doing with eBPF that is not related necessarily to what's happening with Cilium. So this is a good way to do it.
Cool.
Lots of talks there this year. And then obviously the big show. And if you want to know what we're going to be up to at the big show, this is where you can find out about it. We've got lots of stuff, obviously, talking about like Cilium eBPF Day, lots of other talks. I did not get any talks in this year, so I'll just be, at the booth and talking with people and like generally being a nuisance, that kind of thing.
Agent of chaos.
Agent of chaos. Exactly. Stick with what you're good at. That's what I say. So next, I would say that I'm gonna actually stop sharing and let you share, so you can talk us through this repo.
I recognize that.
All right, it should be.
Scroll down just a little bit, because when I start sharing, I'm going to show my VS Code.
Oh, okay.
So stop right there. See that open in GitHub code spaces?
Yes.
Okay, people are going to get really annoyed because I constantly say code spaces. But you can just like click that button for anyone in the audience, or, Duffy, I think you've already tried it. You can just like click the thing and then click create code spaces, and you have the entire demo just ready to go with all the dependencies and all that magical stuff. So anyone who wants to like throw stones after showing us how dumb our demo is, or my demo, your code I know is going to be amazing, but
right,
yeah. You can throw stones by, and I'm going to remind you of this, submitting a PR, so that we can all learn and evolve and enhance things together. It's called learning in the open.
And I did that.
You did. You are an awesome person.
So this is the PR that when Kat and I first met, we were talking through these things, and I submitted this PR with this change.
Yes.
Basically enabling Hubble and disabling the native routing cider and letting it to be default.
Yeah. So we can talk about like why we did those things. And if you want me to share, yes, I'll go ahead and start covering the bases from the top.
Come on.
Sweet.
Oh, there we go.
Okay. Right. So yeah, this is a pretty familiar view after seeing what the GitHub repo looks like. So over on the right, that's our directory layout. Our most important file here, we're going to jump into in a minute. It's that index.ts. But okay, so today is all about running kind Kubernetes and getting going with Pulumi by deploying our CNI, which of course we're going with Cilium because Duffy is Cilium the best?
Obviously, 100%.
Okay.
Yeah.
So according to Duffy, Cilium is the best, which is why we coded it up in Pulumi, because Pulumi is the best. I don't know why we would say that, but I've been saying Pulumi was the best since before joining Pulumi. So
Pulumi has that incredible advantage to it that it is a second innovator, and to some degree, Cilium has this advantage as well, where like there has been a bunch of work in a particular space, and you decided to take a lot of the lessons from that work and make something even better or even more amazing. And I love that.
Yeah, no. I feel like so just to like Cibo Navigate. And I honestly feel like Cibo Navigate is one of those like It's riding off the same advantage of not having to operate legacy, a mountain of legacy, hypervisor code.
Yes.
And they're just running directly with kubevert, which we also deploy with Pulumi, by the way. But yeah, let me go ahead and... So if anyone wants to follow along and they've launched their code spaces, or if you don't want to use GitHub code spaces and you just want to clone it down locally, all you need is VS Code, the remote containers, or AKA the dev containers plugin, and Docker installed because, containers. And then at that point, you're pretty much good to just go with the README, copy pasting your way through, which is what we're going to do right now. And then while that's deploying, we'll take a look at the code and see how the magic happens.
I'll admit, as an agent of chaos, when I ran this, I just basically ran like make kind, and then I tuned it a little bit, and then I did Pulumi up. I totally didn't read the instructions.
So no. I can't throw shade because I write a ton of instructions all the time. And then I'll come back like a year later and be like, oh yeah, I totally know what I wrote. And I won't read the instructions that I wrote. And without fail, I will not follow the instructions.
Yes.
And then I'll run into a problem that I've already solved before.
Oh yeah,
and I'll lose 2 hours on it.
And included in the said instructions.
Exactly. After I feel so victorious from solving the problem, I'll go back to square one and be like, I need to update the docs to include a fix for this. And sure enough, the docs are already covering the problem.
Yes.
Yes.
Yeah, that trick never gets old.
I am my own worst enemy. Okay, so we will have a kind of Kubernetes cluster pretty soon. In this repo is unmerged. Well, it's not. It's in main, but it's just this crazy little extra directory here where the whole thing is running yet again, but with Civo Kubernetes. Mm-hmm. By the way, did you know that Civo Kubernetes 1 supports Cilium out of the box, and 2 supports 2 different kinds of Kubernetes, that being K3s and Talos, and 3, Cilium out of the box on Talos is not supported, which you will get a warning about in most cases, but not all, if you provision your Kubernetes with the GUI. However, since we know that GUIs are not production methods of deployment, what is interesting to note, and I need to file a bug on this for the Pulumi provider, there is no error which informs you that, hey, if you configure your IAC to deploy Cilium and Talos, it will not complain when you actually Pulumi deploy.
Oh.
Same for the Terraform provider. So yeah, we're in that situation. We're probably going to have to fix it in the Terraform provider side, since this is a bridged provider and not a Pulumi native provider. Pulumi native being we don't rely on the bridged spec to inform our provider. We manage the API spec natively.
I was going to ask. I mean, I've been following Civo for quite a while. They're awesome folks, and a bunch of my friends work there. But I am super curious, why that's not supported in, because I know that you can deploy Cilium and what do you call it?
Talos
together. That's been supported since
pretty
early on. Yeah. So I'm not sure what that's about. I'm curious.
Yeah, I'm guessing it's just that it hasn't been coded up to actually edit the machine configs, and it's probably just, sitting on a backlog somewhere, and it needs to be done, but it totally should be done because Talos is the coolest Kubernetes on the block. Okay, so we have our kind Kubernetes cluster, and now we're waiting for some pods to be ready because they don't have networking. So we're going to do our Pulumi up next. And today we're going to be smart and follow the directions, because I made the mistake of not following the directions last night when doing a similar demo.
Oh, which part messed you up?
Well, I was doing a similar demo on totally different code base for deploying Talos, Kubernetes, and Cilium, and kubevert, actually, which is super fun to play with in code spaces.
Wow.
So yeah, you can do like full on like advanced production like home labbing in code spaces without even needing hardware. In case, people want to learn more about that, we do stuff like that. So we just did a Pulumi login and Pulumi install. In the case of the login, that just gives us access to whatever state file we're using or state file service. So if we're using S3 or we're using the Pulumi cloud or the self-hosted Pulumi cloud, that login just gives us access to actually be able to store our state or read from our state so we can reconcile what API calls we're going to end up generating with Pulumi. And then this is setting up our stack. We're going to not change the stack. Yes. So obviously with IAC, you can deploy the same IAC multiple times to different targets. In the case of Pulumi Lingo, our stack is our unique target. That's what we attach specific configuration to and such. We don't really have configuration much for this demo other than there is a demo app and we can choose to toggle on and off the network policy in this other Civo Kubernetes code example, and I need to like backport that up into this main example that I don't rush 2 hours right before demo time. So now we're going to do Pulumi app. All right, so I have environment variables set with direnv on this thing. So that's a terrible practice for prod, but we don't do Pulumi up for prod, right? We write a pipeline and then we promote through Git PRs. So my crazy environment variables for YOLOing all the time are not bad practice. They're just not production practice.
Fair enough.
Yeah. But when you do a Pulumi up, if you don't have that, you get this preview, or you can run the Pulumi preview command, which just kind of tells you what we're going to create. And if it's already created this stuff and you just have a small delta, it'll show you just the delta that you're actually changing. But then I also have a lot of overly verbose outputs, just so like we're deploying Cilium with a Helm chart, for example. And this covers all of the different Kubernetes that the Helm chart is deploying. So just for like demo purposes, I went ahead and threw that together. And we're going to look real quick at how we get this server IP, because Cilium wants to know the Kubernetes API service IP. We have to set that in the Helm chart, right? If we were going to do that with like Terraform or something, we would be wrapping this in Bash or wrapping it in Ansible or manually penciling in the IP address. And that ends up being different and having different ways of looking things up, depending on if you are running in Kind or Talos. In fact, Talos with Kube Prism, you're just calling it localhost and hitting the 7445 port. And in other Kubernetes distributions, it can be a little bit weird from Kates to Kates. So I actually wanted to show how that happens in code, because one of the things I love about Pulumi is we can do the equivalent of kubectl namespace, kube system, get Kubernetes service, so that we can actually see and parse. It's almost the equivalent of like using the JSON path flag with kubectl to actually parse out where we're going to pull that IP address. And this is where we actually do that. So we're just fetching the Kubernetes endpoint.
So is this a TypeScript thing, or is this?
Yeah. So this IAC is written in TypeScript. Of course, Pulumi supports Python, Go. There's .NET people out there that love the .NET stuff. I'm not really in that space. I couldn't say. We have Go and C# and other languages. I mostly do Python right now because, everybody's going after the AI space. I do some TypeScript, and I've done absolutely zero Go since joining Pulumi, and I'm not sure why.
Oh, wow. Trippy.
I know. I did more Go Pulumi before joining Pulumi. Go figure.
Huh.
But yeah, so we're just looking up a Kubernetes endpoint by name, specifically by name there. And then here we're actually figuring out how to parse the JSON response to pull out the endpoint IP address. And we assign that to server IPs. Now, in kind, we just get one, but that is an array. So we end up pulling it out of 0. And that's probably not the safest way to do this, but it works for demo purposes right now. So in production, you'd probably have a more rigorous function to actually assess what IP you're going to feed in. Because for like, if you run this function on Talos, you're going to end up with a list of IPs for the VIP, which is your floating IP between the control plane nodes. And then you're also going to get the 3 other IPs directly out of hello, you're also going to get the 3 other physical IPs for the control plane nodes. So
makes sense. Yeah, frequently
Yep,
you'll have like a load balancer or something that you're going to put in front of these things. And
Yep.
like knowing what that is ahead of time is probably the best.
Yeah, I forgot to turn on vid mode, so I'm in here like hitting keys and changing code, and that's dangerous.
Yeah, fair.
Okay, so we should be deployed. Yeah.
Sweet.
And no, again. What? Cat, stop changing things. Okay.
or turn on Vim mode. One of the two.
No. Like when Vim mode is off, that's when I'm in trouble. I have it set to off by default, but if anyone is trying the demo and they want to turn Vim mode on, just Command or Control Alt Shift P, I think, gives you your command palette, and then you type Vim, and it'll give you that toggle option so you can turn it on and off. I can't use VS Code without Vim mode. I would still be in Vim. And then if we really wanted to like poke around, K9's is in here. And we can see that all of our pods are running, including a demo app. But I don't think we're going to play with this demo app, are we?
We're probably not going to. But I do know that you've like enabled some things in there, which I thought were pretty neat. And I do think one of the things I was going to ask was, is there are 2 binaries that you can download from Cilium. One is the Cilium binary itself, and then the other one is the Hubble binary. Do you have both of them in there?
I have the Cilium binary. I did not know about the Hubble one. I don't. No, I don't. How do you grab the Hubble binary?
It is.
Because I can add that to my dev container pretty easily.
It's going to be Cilium Hubble, and it's like in a lot of the repositories or github.com/Cilium/Hubble. And then you can just grab the release from there.
Okay, so I am going to drop an item on my repo to add the Hubble binary.
Yeah, like if you use Arcade or any of that stuff, it's all going to be in there. Like it's in a lot of places.
Yeah, actually what I end up doing is just curling down directly from GitHub releases after using JQ to parse for the latest version.
I like it. That works.
Okay, well, I added an issue.
Well, I will show Hubble after we get this merge done then.
Sweet. Okay, so in that case, what about the merge?
Let's talk through that. So
cool.
I was able to bring up this environment, and I was totally like chaotic about it. I basically just like did a make kind, and I tuned a little bit on the make kind thing, and then I just did Pulumi up, and I got everything to work. And that's how I actually worked through the process of enabling Hubble, which is, and I think we showed those changes already, with basically just a few more values that we needed in here that basically just enable that. But one of the other things I was going to point out is the reason that Cilium wants to know the server IP is because you are using kubeproxy replacement mode. And the wild part is that kubeproxy actually also needs to know the server information. So it's really just like one side or the other, like one way or the other, if you're going to have something that is going to configure and do all of the work that kubeproxy does, which is that whole internal load balancing mechanism, then it needs to be able to talk to the API server in the absence of the internal Kubernetes service operating, because it is going to be the thing that creates that internal Kubernetes service,
Oh,
right?
okay.
Because there's no load balancing
Yeah.
until like,
Yeah.
totally
No,
circular
like,
dependency kind of game, right? Like
not having the CNI like built into the entire like kubelet rollout and everything does feel very chicken and egg-ish.
Oh, yes. Yeah.
Yeah.
And it
Like,
is to a great degree, but this is the one point where we're like, no, the egg came first. Like this is how we do it, right? This is the moment in the configuration where we're like, clearly somebody needs to tell somebody something, and it's going to happen
so
here.
we have
Right?
solved paradox today. I just
Yes.
want to shout out that we solved paradox.
Exactly.
All right.
Yes. So that's why you have to go through that whole process. And if you were to just run kubeproxy and not let Cilium do kubeproxy for you, then you would not have to provide that, because effectively kubeproxy would provide the internal load balancing. It would be, and for most environments, that's enough. Like, it's not I wouldn't say that us replacing kubeproxy is a requirement in anything less than like probably 3,000 to 5,000 nodes. When you start getting into larger clusters or clusters that have a lot of services that are constantly being updated,
Yep.
then Cilium doing kubeproxy is the way you want to go, because it's way more efficient and it doesn't have any of the same convergence problems that IP tables has. But
see, I haven't actually done production. I do a lot of break glass and like
yeah, me too.
R&D delivery and stuff like that, and then I throw it over the wall and say, hey, this is the idea I came up with. You guys have to make it production ready.
Right? Yeah. Good luck. Have fun.
But we do Cilium hardcore when we do Cilium. So we went full strict mode.
Exactly. Yeah. And it's interesting stuff like, but what I'm pointing out is that for most of the lab environments, it's probably not absolutely necessary that you do it. But and it may simplify the deployment if you don't do it. But at the same time, like when you start getting into like churn, when you start getting into lots of services, lots of applications, that's where you start really seeing the value of it. Up until then,
gotcha.
We do it and it works great, but like you're not really seeing the value of it until you have that problem that
you're just prepared in advance for future problems if you encounter extreme success.
Exactly.
Which we hope you do, right?
And to your point, I have a very good friend who says, design for scale always, right? And I like that. I like that mentality, because at that point you're realizing, while I might be trying to solve a problem that is in my hands, it doesn't mean that the next problem isn't waiting right behind it, right?
Yeah. If you're going to take on a challenge, I mean, there's an amount of walking the fine line of scope creep versus full on constant, like last second, like covering problems only as they actually service instead of like covering them before, when you can anticipate them before they happen. Yeah.
So let's take a look at this new pull request.
Yes, let's do. Do you want to share and you can kind of tell what's happening in your PR? Because I haven't actually looked at it.
Oh wait, I accidentally just did unshare. Let me do that again. Share screen. Entire screen. That one. Share. And put it up there. Boop. Okay. So I was looking at the sample app, and I decided to add this sample app that we use at to demonstrate all of these things. And it is in the form of a Helm chart, but it's not hosted anywhere. So I decided to just kind of put it up underneath a new directory inside the repo called charts.
Okay.
The chart itself is the chart itself.
Are you going to be publishing the chart at any point, or?
Yes, probably. Yeah, it makes sense to do so. We just haven't done it. But the chart itself is called Jobs App. And inside of the chart itself, it's basically made up. It's got a few dependencies. It's got a Kafka operator and Elasticsearch. And basically the app is it's kind of like a jobs app where you're like reviewing resumes and those sorts of things. But fundamentally, like the thing I like about this chart, which makes it super useful, is that it does all of the setup for you, creates the whole stateful application, it starts generating traffic back and forth between things. And if you look at the values for the chart itself, which is here somewhere, blah, 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 values. Nope, that's the strategy values. It's really kind of hard to see from this perspective. Charts, templates, I don't want that. There we go.
Is it that top level values there, second up
Right
from the
there.
bottom?
That's the one.
Sweet. Awesome.
So in the values, you
Yeah.
can see that like it's going to basically enable, like, or it gives you enable or disable until it sets particular memory and CPU levels. How many replicas, lab environment, one replica is fine, one topic, creating Elasticsearch, doing a similar thing. Again, just kind of creating enough bare bones template code to actually stand it up. And then in network policy, which is interesting, you can, this is actually talking through the Cilium network policies that we create for this infrastructure. One of them is just enabling network policy at all. Then we have HTTP ingress visibility, Kafka visibility on ingress, HTTP egress visibility, and Kafka egress visibility. So you can turn these particular things on or off, and that will change what you see in Hubble depending on what you have turned on, right? And then debug, giving you a little more information about what's happening here. Another thing that we're able to do with this, which is pretty neat, is that we have enabled it to support OpenTelemetry. So this would be enabling the tracing features of the application stack. It's not a requirement that you do enable it, but if you do want to enable it, then it will basically give you the ability to point toward your OpenTelemetry exporter, HTTP and gRPC endpoint, and get all that stuff going. And the same thing on down the path. The application can also support TLS. It's not enabled by default, but if you do want to enable it, you can.
Cool. Get some cert manager action going in there.
Yeah, lots of stuff in here that are pretty neat. I like the core API actually also has an error rate capability, like how many requests should be related, how many requests should be errors, how many of them should have a sleep rate, what's the sleep rate upper bound, just kind of giving,
cool.
Making the application do a little bit of chaos testing in a way so that you could actually understand a little, like make things more interesting for the graphs that you're trying to show around all of this stuff.
Okay. That's really fun. I'm assuming we wouldn't normally put that in a production app. We would do chaos engineering a different way, but yeah.
And in this case, it's just because it's easier to just build it in there. We just built it in there.
We'll just on purpose add bugs to the application for fun.
Right? Yeah. Because, chaos. And it's fun stuff. So that's basically the app, and that's why I wanted to bring it up, because it actually just kind of really shows off the power of Hubble and some of the other stuff that we've been working on. So I figured let's just go ahead and get that deployed. And in the index TS that we were talking about before, what I've done is I've gone ahead and I commented out the demo app. It looks here like I deleted it, but really I commented it out. And then I went ahead and made a new jobs app Helm values.
Okay.
And I set the network policy up the way I want it. And then I created the new jobs app Helm release. And in this case, I pointed it at the file. So it's like a local chart for the Helm release. And then I...
So actually, I like how you set up the Kate's Helm v3 release. Also, by the way, because this actually came when Duffy and I were planning this, in the Pulumi registry, which is where you find all the different Pulumi providers, Kate's Helm v3 offers chart and release, and both of those things will deploy Helm charts.
Yes,
right
locally or remotely.
Right now it is tribal knowledge, but I'm afraid hey Marino, but Helm release is what you want to use. That is the current gen. Helm chart is there for backwards compatibility. It is the older method of Pulumi Helm chart deployment, and it's not as polished. You run into some weird things with like hooks and crazy things like that just aren't fully implemented there, and we kind of had to go back to the drawing board, and Helm release worked really, really well. So Duffy, you pointed out that you can actually deploy Helm charts from local disk instead of having to have them remotely published. I had not practiced that before, so that was super cool to learn about. Thank you for kind of figuring that out.
And the other one that hung me up was because we're using a Helm release to deploy Cilium, and this chart, the jobs app chart, actually makes use of some of the CRDs that are installed by Cilium, like the Cilium network policy stuff, right?
Yep. You got that depends on there so that it doesn't try deploying until those CRDs exist.
Exactly, because initially I was like, no, that's not working, and it's very clear to me why, right? So I needed to get that.
And a lot of things can deploy in parallel, right? Which is fantastic for just speeding up your deployment, having more efficient ops.
Yeah.
But in the case of depending on like a CRD or something like that, being able to tell it not to yet is really helpful. What I like about how you did your values there, though, is in the code base I was showing off last night, we deploy to Talos Kubernetes, we deploy to Kind Kubernetes, and our Helm values end up being different for the two different targets.
Mm-hmm.
So by being able to just set up a couple different constants for our values, we can then add a really simple Boolean to understand what target it's going to and use the appropriate Helm values depending on where you're headed. So I love how you set that up, and it enables that more intelligent contextual awareness logic in the IAC. So you're just ready to run with adding more,
That's a good point. And then the other thing I also realized is so I was trying to figure out why aren't these things dependent already, because they're in an ordered list. And what I found out when I looked into it was that in the Pulumi world, when they look at this, they're like actually, if I rely on a value or an output from a previous iteration, a previous function, a previous constant, whatever, then that dependency is implicit.
Yeah, actually, so that's really cool, because you're getting into the programmatic, more software developer minded feature set of Pulumi, where you create a resource and then you can inform your your next resources that chain out from that. Even feed Helm chart values based on outputs from previous resources and stuff like that, which obviously you don't have to know everything before you actually run Pulumi up. Something can be discovered along the way. You're still declarative because you're still working on an inputs and outputs model. It's just, instead of manually writing in your configuration, some of your inputs can be informed programmatically in an automated fashion. So I really, really love how you wrote this PR. I'm excited to merge it.
All right, well, let's do it.
Okay, I'm just gonna YOLO this.
Before you do it, I do want to point out one of the changes that I made in this, which I probably should have made in a different commit, but I mean like that.
Well, this is demo code, fast and loose.
Exactly. What I did was I got rid of these.
Rejected. I can't merge your code now.
And the reason I got rid of them,
you're totally calling me out now. But if the pipeline fails, I'm going to blame it on you.
That's fair. Yeah, and maybe I would even be down with increasing weight, right? Or just allowing retain to happen, because at the moment what happens is if you do wait 1 minute and retain, then inside the Kind cluster, you might not even get to the point where you have storage up, because you're never really getting past the control plane.
But that is why I have another task in my CI pipeline, which very specifically waits until pods are ready before proceeding on to deployment.
But the pods that are deployed, so that's what I'm saying, is that unfortunately Kind bring up is a serial process that has multiple steps.
Yeah.
Control plane is the first of 3 steps.
Okay.
If control plane doesn't happen, then join doesn't happen.
So this just takes us back to I'm my worst enemy, and this hasn't bit me yet.
Okay.
And I was just waiting to fix it until after I encountered, great pain, probably during a live demo.
Absolutely legit. Yeah. But this commit does include that change, so just be aware of it. So if it does bite you, then you can be like, go free, it'll be all right.
It'll be completely public on Twitter. I'll just be like, cancel this man.
Yes.
Okay, I'm merging. I'm doing it.
Right. Woo.
YOLO.
What? Oh, look at that. I didn't even have to refresh merged. All right, so let's check this out with the changes. So I'm going to go ahead. Hop
I'm
over
really
here.
curious. So, do you have like very significant faith in this PR?
Yeah.
Do you want
I
to let
ran it.
me? Do you want to let me show screen one more time?
Sure.
I know we're like slightly off script, but I'm super curious. I want to show.
I too am curious.
Okay.
At this stage. There we
All
go.
right. All right. So we're on main. I can get pull. Oh, really?
You have changes?
What? I
Yeah,
changed
yeah.
stuff. Oh, I bet it was my linter doing stupid things. Did I type that right?
Almost.
What?
I think you were on a stale main before we started.
You think? No, because I created this code space right as we
Oh, you
were
did, yeah.
going live.
That's weird. Then I have no idea.
Okay, hang on. We're gonna use a cheat code here.
I'm going to look up the curl command to get the Hubble binary so that when we do get you in there, that you can just grab that
get
binary.
checkout instead of duh. Okay, now we're good. Pull. Sweet. All right, so I haven't destroyed my kind cluster or my deployment. So let's see.
Ah, yes. Yeah. Whether
What
the update will actually
happens?
work. I think it should work. I hope.
Let's do a Pulumi preview. Okay, so we're gonna delete our previous demo app, Merino. We're throwing the demo app under the bus. I'm sorry, you're a casualty today.
Bomb, bomb.
All right. Now we're gonna do Pulumi up and see if it actually runs clean. So and this is where, like, for the non-IAC initiated audience, this is where Pulumi goes. It checks the resources that it already deployed from the state file or the state stored in the cloud. It identifies what CRUD operations. Oh, the TIE Fighter one, TIE Fighter demo app that we did at Cilium or Civo Navigate. Cilium Navigate. That sounds cool. I would go to that conference.
Right.
But yeah, so we're reconciling against our known state, identifying the IAC that changed, deleting stuff that doesn't exist in IAC anymore, and deploying stuff or updating stuff that has changed or been added in our IAC.
And this does take a minute for it to actually apply.
Yeah, it's taking a minute. I'm not going to do, we could look in there, but I'm just going to make a new terminal.
Because it's a stateful app, so there's a bunch of stuff that like has to deploy into the jobs namespace that like complains for a while until it finally hits, and then when it hits, it has everything.
Yeah. Okay. So you said you have very high faith, and it's still progressing. So there's a chance. I might be a Duffy believer after today.
Although it doesn't look like it deleted the Death Star. I thought I saw the deletion, but I don't see it going away.
Yeah, it should end up deleting stuff.
Okay.
But hey, this is the kind of stuff we learn in public when we merge code on the fly live, right?
That's right. Yeah. Making progress.
Drum roll. Okay, Duffy, what's your favorite beverage?
My favorite beverage.
Yeah.
Wow, that's a tough one. I have a lot of favorite beverages.
Okay, let's start with it's a summer afternoon because I'm looking forward to summer. What is your favorite beverage?
I would say an Arnold Palmer, which is a mix of lemonade and iced tea. But
that is very southern. I love it.
Big fan.
Okay, so now we're deleting our previous demo app.
It worked. It looked like it actually did the thing.
Yeah, everything else is looking good.
Awesome.
Taking a little while. Okay, so I'm not worried about showing the rest of it. It's deleting. It's waiting for pods to die. There's not a whole lot else super exciting. Yeah, see, there we go. We created our new stuff. We updated something, and we deleted other things. So our update was for the Cilium release because we changed our Helm values for Cilium. And then our delete was the network policy for our old demo app and the demo app itself. So that's cool. All right, I'm done sharing. It's the Duffy show now.
All right. Boop. So we got that to work. That's pretty awesome. So let me bring up the same setup in my side of things. And what I'll do is I'll do make kind. This will take not too long.
Yeah.
I'm actually just doing this on my local machine though. I'm not doing
doing
that code spaces stuff. No, I'm kidding.
Yeah, no, that's fine. You don't have to be one of the cool kids. You can still, grow up to be one of the cool kids on base.
Like you can be wrong and still be awesome, right? Like it's a thing.
Yes, Duffy, you can.
I can be wrong and still be awesome.
Actually, the kind config. So I had some volumes.
They still happen.
Did you already have those populated with containers?
I don't. I mean, I did a clean, and I cleaned out all of the volumes and everything. So
there's make target for make clean and make clean all. Make clean all deletes all the volumes. Make clean just gets rid of the cluster but retains the volume. So if you're doing a lot of like creation and deletion cycles quickly, at least you don't have to pull containers fresh all the time.
That is an interesting. I hadn't thought about that part of the trade-off. That's an interesting one.
Yeah. That just it accelerates the iteration cycle.
Let's see if we can do makeup. I think this fails for me, but I'm going to try it anyway.
Oh, I haven't used that target much, so it's probably not well maintained. But Pulumi up should work. And yeah, if you have an aborted Pulumi up, you'll see what Duffy just did there. The Pulumi cancel aborts any currently in flight changes so that it can actually go in and you can run another Pulumi up or down or,
Exactly. Now we see the Cilium installs happening.
Sweet.
And then, see, this is the failure I had. This failure is telling me that Cilium marked itself as complete before the Pulumi. Before the second chart was created. So I can rerun and it will run, but I'm just going to wait for my problem is that it takes so long to do these things.
Let's see. So in our IAC, I'm looking at my pods that are deployed just to see of the Cilium stuff. We have Cilium operator, I'm guessing, is what's responsible for deploying or provisioning some of the CRDs. Would that be correct?
That is correct, yeah.
Okay, so it has to wait until the operator creates the CRDs or spins up the pod and creates the CRDs before you can actually proceed on. So we can like, if we wanted to, we could file a bug on the repo and say, hey, we need to wait for another condition until those CRDs exist before we proceed on.
It does kind of make sense because we're using a Helm release, because we are using a Helm release to deploy Cilium. It does make sense to have some other function in the in XTS that is cluster ready, right? And then how we determine cluster ready. Yeah, exactly.
Yeah, a more Cilium prudent way to do that would be to write the entire deployment without a dependency on Helm.
Yeah.
But short of writing pure Pulumi, you either have to accept that your pipeline is going to do weird things if you don't write a conditional check to wait for that CRD, or you write the CRD?
I believe it would work. I haven't actually tried NerdKettle. That's actually a random question from Nuno. Now that Kind can run on NerdKettle Containerd, would Cilium install work on Kind? I don't think that Kind actually. I think Kind assumes that there's the Docker abstraction. But I guess you're telling me that now that Kind can assume the NerdKettle command abstraction, which I haven't tried. So that's true. That's neat.
So I know that they had added Podman a while back as an experimental. So is NerdKettle a new experimental provider? That's cool. I haven't actually played with that CLI yet much.
Yeah, I haven't tried that one. I haven't tried the NerdKettle thing. That might actually work.
I have a Kind provider for Pulumi, like 95% of the way written, and I just need to actually button up the publishing CI, go make all the packages on the different programming language registries and publish it, because who doesn't want a Pulumi Kind provider? So you just write Pulumi to get your Kind clusters.
There you go. So in our scenario, because Cilium was already up, basically just did a check to make sure Cilium was up, and it was. So it proceeded with the next step, which was the jobs app. And so I didn't run into the conflict this time. So now it's just trying to create the jobs app. And then we can take a look at Hubble, and we can take a look at what that feature was that we enabled, and understand a little bit more about what's actually happening at that level of visibility.
Yeah, I haven't actually gotten into any of the Hubble stuff, so I've been looking forward to learning from the Hubble master today.
Yes. Let's see. So can someone post the URL to the GitHub repo that they're working on? Yes. The GitHub repo that we are working on is possessed by Cat. And it's actually in our notes. So in the lower right-hand corner here, you see show notes, hackmd.io/echo live. You can go there and you'll see all of the notes. You'll see all of our hackmds kind of published. And in there, you'll find links to all of that stuff. So this is the hackmd. Let me just make sure I didn't publish that. So even though I'm saying that you would find it there, I'm lying. Now you will find it there. It's number 128. And so the hackmd with the notes and everything else like that would look like, copy, and then we'll go over here and paste it in here. So you'll find a link to the repo right there. All right, so then, do we get them all up? We're almost there. Yeah, there's another thing. There's another way to do the thing that you're doing with the container image caching, which I thought was pretty neat. And
what's that?
I'm playing with this.
So I've run pull through mirrors a bunch of times, which is totally valid.
Yeah, that's what I was doing here.
Yeah.
A pull through mirror for Docker, for Quay, and for GHCR, and just having them running on my system the whole time.
Oh, you got to share that Kind config with me. I didn't know I could actually set that up in the Kind config.
I will happily share this with you. And there's another thing I want to share. Another reason I want to share this with you is that this cappy.sh script, which is not really actually all that long or particularly interesting, what it's doing is it's actually setting up cluster API for Docker. And so you can create Kind clusters using ClusterKettle.
I did not know that was possible.
Yes.
Holy cow.
And in this case, it's also interesting because when you use Cluster API, you still need you need some service abstraction, external load balancer abstraction, to be able to expose those clusters that you're creating.
I feel like you're about to say Cilium again.
I am. So this is a L2 announcement policy, which means that any load balancers I create, any service of type load balancer will be serviced by Cilium, and it will use ARP to announce the VIP that you create for that particular thing. So this CIDR here is 172.18.200. This is actually the Docker network slider that I'm using, and I'm just picking some unused IP space from that so that I can just allocate another IP address in that same range and address that from my host.
I feel like my future demos just like took an evolutionary leap into the future, and
We should definitely, yeah. This is what I wanted to nerd out on you about you before when we were talking about it.
Yeah.
I don't know if that all made sense, but yes.
I'm following at least.
Yeah. All right. Let me see how we're doing on our pods.
That's so cool. Okay.
User link. Almost there.
It's a big app.
Yeah, your thing actually started up way faster than my thing. I'm actually kind of surprised by that.
Like
in the code space, it was
code
like,
spaces is actually awesome. Like if you saw, I didn't even like go for the biggest virtual machine available, right? You can get 128 gigs of RAM in a code spaces.
But it was just bam, you were like already there. I think that's pretty interesting.
Well, and like one of the things I like about it is if I'm stuck behind poor Wi-Fi or whatever, when I'm on the road, I don't have to stress about like demos running slow, pulling giant containers over a slow Wi-Fi, right? Like I just have Azure bandwidth, and then
significantly better than slow Wi-Fi bandwidth. All right, I think we're almost there. Loader is happening.
At some point, I need to get like connected with some GitHub DevRel peeps, and we can go through like really cool Pulumi code spaces, workflows, and stuff. Because I feel like there's a lot more with Cilium here than I've gotten into. I feel like there's a lot more with code spaces that I just haven't even gotten to yet.
That's fair. Yeah. They definitely seem to always be it's one of those things where they're actually kind of constantly improving it for real. Like
the velocity is pretty impressive for sure. Slightly intimidating. I really like that your PR was over 40,000 lines of code added.
I know, it's terrible.
Because of that Helm chart.
Yeah. I should just host that somewhere.
Yeah, or if you don't have a home for it, I have a pipeline that publishes Helm charts on ContainerCraft.
Oh.
I would imagine you have a home for it somewhere, but if not,
I probably do. I just need to put it in a more public space, I think.
Yeah. Or you can publish it to GHCR.
Yeah, I mean, I have hosted other Helm charts, like in a GitHub Pages thing or whatever. That seems to work pretty well. But...
Yeah, that's kind of how mine is set up.
And boy, really taking its sweet time here. While we're waiting, let's do this. So this is the Cilium binary that we were talking about, and you were able to do Cilium status. So with Cilium status, you can see all the things. You can see Hubble UI is running. You can see Hubble Relay is running. And Hubble Relay is an interesting thing. So let's talk a little bit about that while we're waiting for all this other stuff to start. So the way that Hubble works is that whether you have Hubble installed or not, Cilium itself will generate a series of events about what's happening at the network layer for all the things that are known about inside of your cluster. And it will, but unless there's anything to actually reap all of those events, then they just basically die in the bind. Like it's a circular, it's a, what do you call it? An in-memory cache that is a first in, first out kind of event stream on each individual host inside of your Kubernetes cluster where Cilium agents run. And it basically just FIFOs those events over and over time. You can, even without Hubble installed, you can do something like this. You can do kubectl exec ti-n kube system or wherever you have Cilium installed, and then just jump into one of the Cilium hosts with bash. And here you can do another Cilium status, and you can see kind of like the configuration of the world from Cilium's perspective. So we can see that it knows about 3 other hosts, which makes sense. We can see Hubble saying, okay, and there's current max flows and that sort of stuff. And from inside this inside this container, the Hubble binary is here already, so you could just use the one that's here. But the interesting thing about this is that when you run Hubble from inside of a node, the only events you're going to see are for that node, because it's pointing at the events that are local to the node. So if I do Hubble observe from inside here, I'm only ever going to see events related to what's happening on this particular node.
Okay.
Now, if I run Hubble from outside the cluster, or if I even from inside of there, if I set an environment variable that points the Hubble endpoint to the Hubble relay, then we start making use of a much wider collection of data, because what Hubble relay does is it subscribes to those events that are being generated on a per host basis and throws all of those events into in memory FIFO, right? So you now are able to see all of the events across the entire cluster, across all nodes, and be able to see all of those things kind of in one place, which is pretty
So,
wild.
and what we're looking at is basically just packet flows, right? We're just tracing.
It's a little bit more. It's actually it's a little bit more than that, and because you can think about Hubble as a way of, it's a little bit like the most valuable parts of TCP dump. But the thing that really differentiates Hubble is that we can add more data to the TCP dump and see only those things that we actually really care about in trying to diagnose or understand what's happening between applications.
So like
example,
really, really, really fancy grep.
Like really, really fancy grep. Yeah.
So tell me, okay, I know that this stuff is flowing across the CNI, but I'm really curious. Like I am more familiar, rusty, but more familiar with like OVS flows and things like that, right? How does this compare to some older networking SDN stuff like OVS?
Yeah. So that's a great question. So I worked on OVS. I was part of Nicira back in the day. So like
Nice.
it's neat to see that come back. So OVS actually we were still thinking in terms of like being able to expose things like flows and that sort of information with like NetFlow and that kind of stuff.
Yep.
And while that's still
I come from the OpenStack world like a while ago, and I'm okay with leaving that in the past, but it was really neat. Actually, OVS was my favorite piece of it.
It was pretty neat. Yeah. I do feel like sometimes feel like the thing that we created with OVS was so darn cool, but I'm not sure that it like aged particularly well. Like some of the ideas of like being able to do like live migration inside of the same L2 segment across nodes, I'm like, it's from a scientific, I mean, from the science mind perspective, the nerd brain, you're like, man, that's cool. But at the same time, you're like, but did we really need to do it that way? Did we like, that was a lot of complexity for that, like for that.
Well, I mean, at that point, like you're trying to make virtual machines as portable and dynamic as containers, right? And then here we show up with Kubernetes, and I was like, well, we could just do it easier, right?
Yeah, exactly. Yeah. So this is, I mean, it's similar thing. It's a similar thing in that like you have different inspection points, and you're able to collect information about what happened at those inspection points. The difference is that in Open vSwitch, the single inspection point that you had was Open vSwitch, right? Like what switching are we doing? And trying to provide as much context about that switching that we are doing, so that you can understand that like we touched this packet at this time, it came in this port, it was part of this virtual switch, it left through this other port, like kind of providing that sort of a breadcrumb sort of a view of the thing. And the difference in the way that we operate this with eBPF is that our inspection points are actually quite a few more. We have inspection points everywhere that we touch the packet, and that could be as early as the socket level, and it could be as late as NAT translation out to the external interface or two-stack or two interface. And so there's we have a lot more inspection points, and so we have a lot more data about what's actually happening. And further, because we're operating in eBPF, we can do things like transparently proxy interesting traffic to other things that are better able to parse and analyze that traffic.
Okay. So like high
So like I want to know what the DNS query was for this application. Right? Here's the crawler app. And contextually, I know it was the crawler app because it's just the actual pod that made the request. Its request went to core DNS. It was trying to figure out what API.github.com is, and because we're inside of a Kubernetes cluster, it started trying to figure out the search path first. Right?
Okay. So like if you have very conspicuous stuff, you can like send that off to be inspected, whether you're using, you know, programmatic like deep inspection, or if you're like starting to play with AI and try to understand higher level abstractions of what all's happening at a like larger pattern level across your conspicuous traffic.
Exactly. Like here's an example of an HTTP post, right? So I know that it was HTTP traffic. I can see that the verb was post. I can see what the header was. I can see what the post direction was. I was loading CD into this application, right? This is like,
I love how readily accessible this is.
Right? And it's all just, and also like you can see things like Kafka responses, produce correlation, ID 30 or 33 topic, return code 0, the topic resume, right? Like, and this is what I mean by like, if I determine that Kafka traffic is interesting to me, then I can point using network policy. I can actually just say, I want to increase the observability that I have for that particular protocol, for that particular thing. And it really produces a lot more information. And
this is an amazing place to just park and like read granularly. If you're really actually curious, how does Kubernetes do it? Right? Like this is where you actually see the work get done.
Yeah. And it's, you know, and it's actually, you know, what's funny is like, it's not necessarily specific to Kubernetes. It's specific to
distributed,
distributed systems.
Yes. Yeah, that's true. Good point. So I also come from a background with like Kong doing API gateway stuff, mostly kind of getting some eyes on some of the service mesh stuff with their Kuma things, but I didn't play with it a ton. And I'm curious, since we're operating here at the eBPF layer, right? Do we get to actually do like OPA type like network policy at this layer, or would we, if we wanted to actually manipulate packets, is that when we are writing more eBPF programs? Like what is appropriate to do at this layer, and what would be, you know, better handled by other technologies in the stack?
I think,
not to put you on the spot.
Yeah, no, it's a great question. And it really actually highlights there's actually a lot of content out there that kind of discusses a lot of the same level of information. But like what it really comes down to is like at the eBPF layer, when you think about like that, oh, you know, that's really, I wanted to try this. Oh, nice.
You're just full of all kinds of tricks.
That's cool. You can actually see like, you can see Cilium to overlay, Cilium from overlay. You can see like all the different Cilium programs that got created, the tail calls, IP4 to anyway, sorry. Oh, I just wanted to see that. Anyway, what I was saying was eBPF, you can think about eBPF like this. eBPF gives us the ability in the Linux kernel. You treat if you think of the Linux kernel as an event-driven API, right? Which it effectively is, right? So anytime you have a file open, anytime you want to forward a packet, anytime you want to open a socket, anytime you want to write a file to the file system, any character device does anything interesting, like all of those things are API calls. With eBPF, we have the ability to intercept any particular one of those events and do interesting things with it, even if all we're doing is gathering the context about what happened, right? This process opened this file. That file was part of the root file system instead of what's happening, inside of the containers file system, right? Like just that context alone is incredibly valuable. So if all we do is present context, that itself is valuable. But we can do more than that, right? Like with Cilium, we could do things like we could say, because Cilium is focused primarily as a network product, we can say from the Cilium's perspective, we can just take Kubernetes network policy as it exists and implement it in eBPF. So when you write a policy that says app A can talk to app B, but it cannot talk to anything outside of the cluster, then we're able to implement that in network policy and create a set of eBPF programs that will implement that for every packet that moves from app A toward any destination.
Okay, so I know that we're like really benefiting from the performance of the in-kernel eBPF space,
Yeah, we are.
because that gets us out of user land and into like actually real-time packet handling, which is a pretty big step forward. But you mentioned earlier kind of like this starts really showing off what it can do at like 5,000 heavily loaded nodes, right? When do we really start seeing the power of the feature set and the power of the scalability? Because I'm guessing the benefits of those things happen at different points in your production scaling.
I think the feature set is actually accessible really early on. And I'll tell you why. And I think, when I look at like I look at the work that people are going through to be able to enable particular capabilities in service mesh. I want layer 7 network policy. I want to be able to write a policy that says this application can talk to these FQDNs, these fully qualified domain names, but not other ones. Right? That is a policy that you can write in Cilium network policy without anything else. You don't need anything else. You just write Cilium network policy and you have FQDN policy. That's application layer. Or maybe I want application A to be able to talk to service B, but I only want it to be able to do puts or gets. I don't want it to do I don't want to like have it do any deletes or anything else like that. Right? That's again, like that's application layer policy that we just implement as a feature inside of Cilium network policy.
At the like in-kernel eBPF layer, it only just clicked for me that you're doing that L7 stuff at this most efficient like compute layer. That is really, really cool. I am
and to that point, like there are things that we can do easily in eBPF today. Like we can actually parse HTTP traffic, but when it comes to like enforcing like things like a particular verb or enforcing things like that, sometimes we need another tool. And so we rely on Envoy to be that other tool. And the way that we configure Envoy is actually also super interesting because, again, we're operating at that eBPF layer. So what we do is we create a new Envoy listener. Think of it like a virtual host, the way that you would think about it in like Apache or like, some web browser situation or a web hosting situation.
Yeah.
Create a virtual host inside of Envoy, and we configure that to handle the particular use case that we've identified. We configure that local Envoy instance that way. And then at the eBPF layer, we transparently proxy that interesting traffic through that configured Envoy virtual listener, handle the more complex work like dropping traffic on if it's not a post or a get, right? It's easier.
Okay, so in previous employment, several employments ago, I was working in fintech. And we were kind of doing some pathfinding for a bank's journey from VMware to KubeVirt. And one of their like core VMware features is being able to like low effort mirror all traffic in OVS between virtual machines, right? So that they can very, very verbosely enforce audit trails and, prove constant conformity with their security posture. And that's something that like we looked at using like kubeOVN or like taking other approaches to handling that just weren't as clean and efficient in the Kubernetes world at the time.
Yeah.
So like you're turning me into a Cilium like fan right now, and I'm sitting here going, I could have totally solved that problem.
You absolutely could have,
with this kind of tooling, and it ended up being probably superior to what they're coming from.
Yeah, you're absolutely right. And the crazy part is that like even from the perspective of like how do we handle like mirroring, right? Like there's a thing called Cilium. There's a thing called Cilium port mirroring where we can actually write an eBPF program that will just copy every packet that comes or goes from a particular interface to a destination, right? So that low cost
And
way of
because you
doing
have
it,
access to it from the socket to the
right,
NAT,
doesn't get
you
cheaper than
can
that. Because
literally grab it everywhere and make sure that it's not changing in flight and all kinds of stuff, which would have been way harder in something like OVS.
that is true. Yeah.
That's
You know what's
cool.
funny too is that like there are a lot of people who are core contributors who have been a part of Cilium from the beginning, who were early committers to Open vSwitch, who were part of that original effort. And they basically saw, like what we saw in Open vSwitch was the ability to kind of finally virtualize or create software functions that were network functions. And now we're looking at this like eBPF stuff going, wow, like, you know, like Open vSwitch was one thing, but like what we could do with eBPF is just mind-blowingly cool compared to like what we were able to do with OBS.
Awesome.
You know,
Okay. So yeah, I'm definitely turning into a Cilium fan, and I'm kind of happy about it, and I'm kind of angry because now I have an immense new thing to learn. So I will be bugging you a lot
yeah,
now.
I'm here for it. Yeah, I mean, and I do this actually. I do this show like every 2 weeks.
Yeah.
And so like I'm totally down to spend more time like playing with that kind of stuff.
Okay, so what we're gonna do is we're gonna like take my platform engineered home lab stuff and bring it on the show and start like enhancing Cilium on it. Of course with Pulumi, because you know that's what I do.
I'm going to show you this stuff real quick. Jobs app. YAML, allow all within network policy. So this is what I mean by interesting traffic, right?
Okay,
So
let's see what we got.
So this policy, this is a Cilium network policy, and in that Cilium network policy, I'm going to, this is just the allow all within the namespace so that it will not drop any interesting traffic. What I wanted to turn on was the DNS visibility. This is the DNS visibility policy. And what it's doing is it's saying all of the pods inside of the namespace that I'm in, the jobs app namespace, any traffic that's destined for the Cube DNS pods inside of Cube system, if the traffic is passing over port 53 on any protocol, I want to match any pattern. And this turns on visibility, right? This basically means that now, if I have this rule set, when I do Hubble Observe, I'll be able to see that DNS traffic.
Cool.
Without this, I would not be able to see that DNS traffic. I would just be able to see that traffic had moved toward DNS, but I wouldn't be able to like inspect the actual DNS response and query.
Let's say you're not doing like, you know, DoD or public sector, like, or like fintech or like HIPAA stuff, right? Let's say you're not in a really, really high security production environment.
Mm-hmm.
Would you want a policy like this for DNS visibility on a regular basis to feed into your general platform analytics? Or is this something you would turn on during troubleshooting and then disable when you're done with like whatever outage response or debugging session that you're in?
For DNS traffic in particular, I would say it's good to have it on all the time.
Cool.
And the reason I would say that is because, like, in my mind, you know, like it's not as much as it is a meme. It's always DNS, right? Like being able to actually go back and point to the graph and say, see, it was DNS here, and it was DNS here, and it was DNS here. Like being able to actually show that and prove it out, like, actually really helps. Really helps. And also, if you're going to make use of FQDN based policy, then we need to know what those applications or workloads resolved the FQDN to, and when you turn on FQDN visibility, then you can use FQDN enforcement, but you can't turn on enforcement without visibility.
Gotcha. Does this like add like storage consideration for the logs there, or are we still living within that first in, last out?
Still living within that, yeah. And also, like, when you turn on FQDN visibility, we actually also start up like a proxy that keeps track of mapping between FQDN and IP, and that's on a per agent basis. So it's a distributed problem.
Okay.
So the only time you actually ever make use of that cache is if an actual workload is on that node, matches that policy, creates an entry in that cache, etc.
Cool. Sorry for my crazy questions. I'm just like all over the place trying to absorb what you're doing.
Yeah, it's neat stuff. I mean, like,
Very.
I think it's really, really cool. Now, I mean, at the same time, you were saying like, well, what about this other stuff, like HTTP stuff or Kafka stuff? Honestly, I'd probably use that for troubleshooting, right?
Okay.
Like, I could see turning that on for like, or if I had, some production app and I wanted to actually understand like historically what happened, right? Now,
Yeah,
the other thing
if you're doing like performance analysis or something like that.
yeah, and I talked about this a little bit, but there's a lot of options inside of Hubble that give you significantly different views of the data.
This
Right.
is why we have people who are network engineers, and that's all they do.
Yeah, it's true. But like, when you're trying to understand like, to FQDN, from identity, from IP to IP, you can have you can have a negative match on things. You can have like, you want to look for particular TCP states, you care about SYN, or you want to see how many fins there are, etc. Like all of these different ways of filtering this data give you the ability to kind of understand a little bit better about what's actually happening on traffic across all of the clusters. Right?
Yeah, no kidding. Wait, you said clusters plural.
I did actually, yeah. And that's another thing that you can do with Cilium is you can create multiple clusters and you can peer them so that all of the pod networks are basically one big flat network.
So you're doing some kind of like mesh equivalent at that point?
Yes, exactly.
So, gosh, every answer just leads to like 5 more questions for me.
It's a never-ending rabbit hole. Yeah,
it really is.
Is this time when I get to suggest labs? Oh, all right, fair. Raphael is pointing out. Actually, there's one other thing here. When the One Piece journey starts for Cat. Yeah. It's true. So there is a really good, I will point out the amazing work that so many of the people on our team have done for so long to make all of this easier to learn about. So these are the labs that are available today, and they're constantly being updated, and they're constantly being added to, and they're just a ton of really great quality labs. Cool. Where you can actually go and for free, like this is all hosted in Instruct. So I guess in some ways kind of weirdly similar to like a code space, but like this is all like in Instruct where we run all of these things and you can actually walk through the steps to understand better all of the things, including things like Gateway API or implementation of Gateway API. You want to play with BGP on Cilium, like L2 announcements. I talked about that earlier with like the cluster API stuff.
See, if I ever run out of ideas what I'm going to do with Pulumi next, I'll just like show up here and be like, I'm going to recode this example in or this exercise in Pulumi. And
exactly.
Yeah, that sounds fun.
So tons of really great stuff, including like, like what I was saying, Cilium is kind of focused on what's happening in the network layer. Tetragon, which is another product in our portfolio, is actually focused on what's happening at the kernel layer. And that's going to be a rabbit hole for a future episode, I think.
Yeah, I'm not ready for kernel brain today. I had my son is homesick and I had a long night, and brain is not going to go into kernel space. I've done bisecting before, and I don't do it on a regular basis on purpose.
Yeah, I get you. But yeah, so that's what I wanted to show you. I wanted to show you the Hubble stuff, and I turned that on in your lab, and I also gave you a different demo app that kind of shows all that stuff off. And I'm super excited about Pulumi. I think Pulumi, I've been friends of Pulumi for a long time. I've known Joe and those guys. And it's funny, like my first name is, Joe's last name. So it is.
That's true.
It's really weird that way. But
wait, who are we talking about?
Joe Duffy.
Who's on first?
Yeah.
Yeah.
And so, I think it's a really great project. And I was actually kind of having fun writing it. This is one of the first times I've had the opportunity to do any like actual writing of Pulumi code, and you gave me a great jumping off point. So
okay, so let's do this. I'll say my biggest takeaway from Cilium today, and you can say your biggest takeaway from Pulumi today. Can I put you on the spot for that?
Yeah.
Okay.
Go me first.
I'll go first. Okay. So, all right. So, like, I've recently been like induced into the Cilium world just superficially in the last couple of months, and I have found it really, really like a gateway drug to being curious about network engineering all over again.
Mm-hmm.
And I feel like that speaks really well to it being easy enough to deploy to get started, even if you don't know what you're doing yet, and really amazing at giving you the deep insights you need if you are in the middle of an outage or a crazy pre-prod debugging session. And like, I have to admit, like, people say Kubernetes is hard. Kubernetes in production is hard. Like, in all fairness, that's hard. But like, using Kubernetes for just basic personal interest needs isn't crazy complicated, because you just have to remember it's just scheduling a process, hooking up some networking and attaching some storage, right? And those in a non-prod, like, you're not thinking super hardcore about security posture or things like that, those aren't really that bad. So especially if you're doing it in IAC and you're not like just trying to memorize a bunch of kubectl commands,
Yeah.
And having that Cilium like deep insights to what's actually happening in your cluster, that's cool. And I've been missing that. Like, quite honestly, when I was in OVS doing like kubevert or OpenStack or whatever, I had access to that stuff, and I haven't relearned how to get that visibility in Kubernetes. So I feel like I actually have answers for that now, and that's my takeaway. And it's a really, really cool like thing that you shared and taught us today. Okay, you do not have to like meet my high standards of how to talk really well about a product. Your turn. Go.
Yeah. So I remember, so I actually just recently had an experience with Pulumi that I thought was kind of eye-opening for me, which is that like when I was trying to create an environment in Terraform where I had a Terraform kind provider, and then I wanted to deploy Cilium onto it. And the challenge was that Terraform's view of the world is it has one opportunity to learn state about things that it will apply to, and that is before it starts.
Yeah.
Right. And so you kind of have to know a lot about the world before you can actually apply Terraform to it. And even if you're going to create something, right? So like I create a kind cluster, and part of the output of that kind cluster is a configuration like the kubeconfig that I would want to use when going to the next step. Terraform doesn't allow for that mix. It doesn't allow for you to take an output and make it dynamically a part of the next thing that you're going to do. Whereas like, that's more of a control flow thing. That's more of a coding thing, right? It's like if you're going to write program flow, that's like, that would be, I've made a thing. I want to take that output. I want to pass it to another application or another function, etc. And that for me is one of the killer things about Pulumi, is that you're not like stuck in that state model, right? You're actually in a place where you can be pretty creative about it. Like you can actually, like we were talking about earlier, you could say, you know what, for whatever complex, baseline Kubernetes cluster I care about, I could pick those things that are going to indicate to me that that cluster has reached a ready state carefully. And when I have picked them and I see them reach that ready state, then I can actually set a Boolean within my code that says, now the cluster is ready. Do the things that depend on that, right? Like,
yep.
Very cool.
That inputs and outputs for each resource thing is kind of life-changing, and just lets you think about solving problems the way that they exist instead of the way that the tool makes you.
Yeah.
And no, I couldn't have said it better myself. I love that call out. Yeah. Yep. Super cool.
I like it a lot. Thank you so much, Kat, for joining me. I look forward to our next session. I'm sure it will be equally as interesting. I personally kind of want it to be around the cluster API stuff, but I can also understand that like maybe that's not the thing. We'll see.
No. So like Cappy is like KubeVirt and Cappy like go hand in hand for me. So we can totally get into that on a bare metal cluster if you're at game.
You're going to really, I think you're going to find it interesting because I'm going to show you also a whole different provider that doesn't make use of KubeVirt. So KubeVirt for a while, so there's a new, this is my exiting thought. I'm going to try to make it.
I know. I am so.
We can geek out about this forever, but
yeah.
There is a really great project. I'm going to share my screen again, and I'm going to tell you about this because.
Are we doing cloud hypervisor selling now?
It has the worst name of any project. I think Cloud Hypervisor is like just an absolutely trash name. But Cloud Hypervisor is a Rust-based BMM. And in Cluster API, it represents a way of doing things that is, in my opinion, fundamentally better and more efficient than KubeVirt.
Okay.
And I want KubeVirt to adopt it. But it has not happened.
Okay, so in fairness, I don't think QEMU is the world's pinnacle of virtual machine management. It's not. But I do think the KubeVirt, really GitOps friendly.
Some of the wrappers around it, yeah, for sure, yeah,
is badass, honestly.
Yeah. But yeah, neat stuff. But we will play with this in some future episode. Thank you
cool.
so much.
Stay tuned for future episodes. Yeah.
Enjoy yourself. I think we have one last comment from Sebastian. What does he say? Thank you both. You're great. Yeah, we could geek out all day, and he can listen to us.
Yeah, you can replay on repeat. Catch you later.
See you next.